in the class or from the web, you will get a grade of minus 100 if the maximum grade for the homework is 100. Okay. So we have some ways of checking it. It is enough just to have a single line similar to somebody else's code. A single line of code similar to somebody else's single line of code is enough for us to give you a minus 100. Okay? So don't try to take the homework and try to modify that kind of stuff. That's the honor code. Topics to be covered are these. We will do the general introduction first. The chapter 1 of this book is very introductory, and it is very general, and it provides lots of information about it, information about the operating systems. After you take this class, and if you try to remember what this class was about, or if you try to remember what the operating systems was about, come back to this book and read chapter 1, the general introduction. It talks everything about the operating system. It's a very good chapter. So we will be covering the chapter 1 first. Then we will do processes and threads, memory management, file systems, input, output, deadlocks, virtualization and cloud. This is a new chapter actually, and the security. If we have enough time. Okay. These are the topics that we will be covering in this lecture. Okay. Any questions? Yes.
Which C++ dialects we can use? C++, 11, 19.
You could use any. Actually, as I said, we are going to use G++ and Java compilers. Okay, and it might depend on the homeworks. We will be providing the homework submission instructions. Okay, I expect you to write make files. Okay, make files. I couldn't write it. I expect you to write make files, and when you submit it, we will compile your code and run it that way. If we want a demo from you, sometimes we will want demos. Okay, you might do some demos. You will not use the development environment for your demo. Okay, it will be a make file, make it, compile it. There will be executable code, and we will run it. Okay. So we will provide you specific instructions. We will provide you specific instructions for each homework. Okay? But if you are asking if I can use the C++ 11 or something, it depends on you won't need to actually. I think the most basic C++ or the Java would be good enough. Okay. Any other questions? I guess that was it for the syllabus. Then let's start the lectures. If you have any other questions. Okay. Yes, this is the okay, these are the slides from last year. I modified them with the contents of the new book. Okay, so first let's look at why we are studying operating systems. Operating systems are actually by themselves they are very complicated, and they are kind of both easy and difficult to understand. That's why sometimes people are calling them like magic. Most people don't understand them, including the system administrators and computer scientists. In fact, those graduate study exams, lisansüstü için gelenler, most of the time in those examinations, I ask this simple question: what is an operating system? And most of the time, people can't answer it at all. They have the BS degree, lisans dereceden almışlar, but they cannot answer this question, the simple question of what is an operating system. So most people don't understand that. They say that when I say that what's an operating system, it's like Windows or Linux or OS 10, that kind of stuff, but they cannot see it. Okay, they are incredibly complex. When you write a simple C program, it might look like the Hello World program. It might look like it's like 5 lines of code. In fact, it's actually million lines of code underlying this Hello World program, because Hello World, in order for Hello World to run, it needs the compiler. Compiler has lots of lines of code. The Hello World uses the console and the keyboard, the screen drivers or the video drivers and the keyboard drivers and the memory management, uses all kinds of stuff. They have lots of lines of code. So Hello World in this simple form has 1 million lines of code underneath, if you consider all of the supporting programs and operating systems. That's why we say that they are not that easy to understand and to grasp. Studying operating system is learning how to deal with the complexity. Okay, operating system does a few things. Okay, first of time, it provides some abstraction. Writing a Hello World program is very easy, because it's just 5 lines of code, because it provides you the operating system provides some abstraction for you, so that you don't deal with the complexities. Okay, this way we would know, by studying operating systems, we would know how to use abstraction. Also, the other good programming practices, modularity and iteration. We will be talking about these 3 things most of the time. If you are not modular, if you are not separating your modules from each other in the operating systems, you will not be able to write a good operating system or understand it. Or if you don't understand what iteration means, you will not be able to develop good operating systems. Operating systems today, for example, if you think Microsoft, every other year, every 2 years, they bring a new operating systems, Windows, Vista 7, 8, and that kind of stuff. Or if you think about OS 10, it has all kinds of different versions, like the Leopard and the Snow Leopard and the Yosemite and that kind of stuff. Iteration is in the philosophy of the operating system. We will be talking about all of those stuff later. Okay. When I say understanding an operating system, okay, we mean understanding the workings of an operating system. Also understanding what really an operating system is. Okay. If you understand an operating system, then you will start writing very efficient and correct application code. If you know what is working underneath, in order to write this program Hello World, you don't need to know any operating system internals. Actually, it's a very simple thing. But if you know what kind of environment this Hello World is working on, then you will start writing very efficient code. So that's the second thing why we are trying to understand operating systems. Okay, we will try to write efficient and correct application code. So teaching operating systems or learning operating systems is not for writing new operating systems. Okay, it is for writing, most of the time it is for writing correct application code. Okay. Of course, the other thing is learn to design operating system or other computer systems. Well, not many people design operating systems. Okay, they don't. Most of the programmers or computer engineers, they don't design operating systems. But sometimes you work at environment like embedded systems. In embedded systems, you don't have much operating system actually. The machine is you work on the machine itself. Okay, you work on the machine itself. It's a very, very primitive programming environment. But if you know the operating system concepts, okay, then you would write more efficient code for the embedded system too. because you would know that most of the problems are solved for the operating systems. If you follow similar approaches, then you will be okay on those kind of systems too. So operating system is not a very abstract class. We are not teaching it so that you will know what is inside an operating system, that you will be knowledgeable. We are teaching it so that you can write correct and efficient application code. Also, if you are working on systems like embedded systems, you would know similar strategies to write good code. Okay? Understand this? Any questions? Okay. So, we would be drawing this kind of stuff all the time. Layer structure, layers. At the bottom we have the hardware. Okay? By hardware I mean central processing unit. Okay? CPU and the network and the memory and the disk and other kinds of stuff, I/O units and that kind of stuff. On top of it, you have the operating system. It's a layer of code. On top of it, we have our compilers and our shells and our windowing shells, that kind of stuff. Okay? So operating system is a kind of layer between the hardware and your programs. Sometimes you put more programs on top of them, okay? For example, here I have a word processor, okay? It works on top of the windowing system. It's the fourth level, okay? You talk to X11, the windowing system. Also, you might talk to the operating system directly. But you will most of the time, you will never try to talk to the hardware, okay? This is not a very good way of doing it. Why? Why don't we talk to the hardware in our programs? Why did they prevent it? Question? Yes?
They are not consistent models. There are changes, different CPUs, different memory types.
Yes. If you try to depend on your hardware, your program will not be portable. That's one thing, because it will not work on some other hardware. Okay? Let's say my hardware is a 64-bit CPU. Okay? If I write an application program that makes this assumption 64-bit CPUs, then my program will not work on other CPUs. Okay? That's why it's not a very good way of writing programs. You should depend on the software operating system, because the Windows operating system, it is available on 64-bit CPUs or 32-bit CPUs or some other non-Intel based CPUs. It is available on other platforms too. So don't try to talk to the hardware. You are not allowed to actually. You are not allowed to. You are supposed to talk to the operating system, and operating system will abstract all the hardware for you, and it will handle all the complicated stuff for you. Okay? So operating system abstracts the hardware. Abstraction is good because for the application programmer, I don't need to know anything about the hardware. It provides protection. What do I mean by this? Provides protection. What am I protecting myself from? What is bad? What is the source of danger, so that I can provide the protection? Nereden geliyor bu koruma? Kimden kimi koruyorum?
Kendi prosesimizi koruyoruz. Birbirlerine koruyan aşmamak için.
Okay, we are protecting our processor. What else? We are protecting our processes from what? From other processes. Most of the time when you write a process, when you write a program, by mistake you will write wrong programs, and that program tries to, let's say, access some part of the memory, and that memory is not his own memory, somebody else's memory. That will crash other applications, not your application, but other applications too. So operating system provides protection between these processes so that they would not affect each other. Okay? And the other thing is manages resources. Resource management. What do I mean by resource management? It means that the hardware is your resource. Okay? Hardware is your resource. Memory is resource. Okay, because there is finite amount of memory. These are resources. CPU is a resource. if you don't manage your resources, okay, one process will take all your resources and the other processes will starve to death. They will not get access to CPU or the network or the disk. So that means that your program, your operating system has crashed. That's why the operating system has to manage the resources. It should divide those resources for the processes in a fair way, in a very, very fair way. Otherwise, more than one program cannot exist on the same machine, on the same operating system. So, operating system does many, many things. These are two important things, and three of them. The first one and the last one is very, very important. Abstraction, so that I can write my applications very, very easily without thinking about the complications of the hardware, and resource management, so that all the processes have fair amount of resources for themselves. Okay? Bunu anladık mı arkadaşlar? Önemli burası. Soyutlaştırma, hardware'i soyutlaştırma. Hardware var mı yok mu alt tarafta önemli bile değil. Ve kaynakların yönetimi, kaynak yönetimi çok önemli. Diğer türlü adamın birisi alıp tüm memoriyi alıp doldurursa, hiç bakmadan yere ya da istediği yere yazmaya çalışırsa, işler çok karışıyor. Operating sistem bunları engelliyor. Okay, any questions? Okay. So these are kind of more explanations about those two things. Abstraction, okay, abstraction and resource management. Operating system, actually it does two things. If they ask you a question, what is an operating system? Your answer would be, it provides abstraction and it manages the resources. That's what operating system does, that's it. It's a very complicated set of software, but it does these two things. Provide abstraction for the application programmer and manage the resources. What do we mean by abstraction? Hides the messy details of the underlying hardware. Okay, hides the messy details of the underlying hardware and present user with a resource abstraction that is easy to use, extends or virtualizes the underlying machine. All three of them makes the programming very easy for us. Otherwise, it would be very difficult to write that Hello World program. Okay, Hello World is very complicated because it uses the screen, right? Writing to a screen using some kind of a window requires lots of code. An operating system makes that writing that code very easy for us. That's why abstraction is very important. Actually, the whole what was the basic principles of object-oriented design from last semester? What was it? It was the first encapsulation. Okay, one of the encapsulation, inheritance, polymorphism, and abstraction. Okay, everybody's there. I am trying to come to the abstraction. Abstraction is one of the basic pillars of the object-oriented design. And operating systems are doing the same thing. By providing a layer of code between hardware and the applications here, I provide my abstraction. Anybody writing a code like that, he doesn't have to know anything about the hardware. All he knows is the operating system API. The second reason why we are studying operating systems, or the definition of the operating system, is managing the resources. Okay, what are the resources in the operating system? The hardware, the processors. There might be more than one processor. It's getting more and more common. Which process will take which processor? It's very important. Memory is finite. Okay, I should manage the memory. Timers, we have lots of timers, disks, or other type of storage. Mouse, the mouse or mice, network interfaces, printers, displays, etc. These are all resources, and they have to be managed. Okay, an operating system does that. And by using these resource management techniques, we have multiple users using the same computer or multiple programs using the same computer. Okay, they share the same resources and coordinates the sharing. Operating system makes them share the resources and coordinates the sharing. These are the two things that operating system, the two very important things that operating system does: manage resources and abstract the hardware. Okay, any questions? Any questions in Turkish? In English? Okay, somebody ask a question. Birileri soru sorsun ya, böyle konuşunca garip buluyorum. Zaten başım dönüyor, 4 tane ilaç içtim sabah. Kendi kendime konuşup kötü yaptım. Soru sorun bir tane. Bana bakın demedim, soru sorun. Eğer bu dersten kalırsanız bunun ikisinden birisini iyi biliyorsunuz. Tamam mı? Açık oldu mu diye. Unutmayın bunu, tamam mı ya? Birileri bunu soracak size. İşletim sistemi nedir diye. Linux'e benziyor, Windows'a benziyor. İşte şöyle var, bunu var. Proses var, prosesi buradan buraya atarken böyle detayına girmiş adam siteden ne olduğunu unutmuş, hatırlamıyorum. İki prosesi getiriyorsun, birisi birisinin ayağına basarsa bu da böyle yapar diye böyle detaydan başlıyorlar. Bunu söyleyeceksiniz. Soyutlaştırıyor, donanımı senden soyutlaştırıyor ve kaynakları yönetiyor. Soru sorusana ya. Bekleyeceğim, bakın saat 50 oldu. Soru soruncaya kadar bekleyeceğim. Şu anda derse getirmem lazım. Benden ders almayan kaç kişi var burada? Bir kişi var orada. Yok mu başka? Çünkü de oradan 102 alıp bu derse gelenler oluyor. Hepiniz benden ders aldığınıza göre bırakmayacağımı da biliyorsunuz değil mi?